All right. What do you call a priest that's also a lawyer? Father-in-law. Okay. Here we go. We've got a cute one today. It's called complementary events. Oh, they complement each other. Now, complementary events, complement kind of means they're just the opposite events. Okay, so I'll explain, we'll do examples, but they just mean they're opposite events. Now, these complementary events, they always sum to the total possible outcomes. And that means the sum of their probabilities is one. And the reason that it's called complement is just it kind of makes the event whole. Oh. All right, so say for example, what's the complement of tossing a head? There's two ways you could write this. It's either not tossing a head, and for this particular case, because there's only one other option, it means tossing a tail. Okay, so they're the opposites. Now, what if I say rolling a one? Well, then again, it will be not rolling a one. That would be its complement. So realistically, it means rolling 2, 3, 4, 5, or 6. Okay. And name the complement of finishing last. So that means the opposite of finishing last is, again, not finishing last. So you can see here the pattern. Probably your key thing here is just whatever the event was, the complement is the not version of it. Okay. The not statement, that should be more than enough. You don't need to write out every other. So finishing second last, third last, fourth, don't have to write that. You just have to write the complement of finishing last is not finishing last. Okay, now a couple things to note here is the notation, which means how we go about writing it. Okay, now what you'll see is if E is your event, so we've seen like the P bracket E, if there's an E and an apostrophe, E dash or E kind of squiggly hat, that's what we use to say it's not E. Okay, so what you can see here is from before we've said that the probability, if I add them together, should sum to give me a whole one. Okay, so probability of an event plus the probability of its complement equals to 1. And I'll show you, this is a nice little mathematical thing where I can find the probability of the complement by going 1, take away the probability of the regular event. Okay, now I'll show you mathematically how these work, one with a proper example and then one with just, I guess, what do you call it? Yeah, just numbers. Okay, now what I'll say here is normally when you use the word complement, they're not necessarily just going to ask you find the complement, but it's useful for events where they kind of have the words not or they've got the words at least. Often the complement is a helpful tool. All right, so let's say find the probability of not rolling a 6 on a regular die or dice. Okay, so again, this one here is kind of just not rolling a 6 means it's rolling a 1, 2, 3, 4, 5. So there's 5 options out of a total of 6. So, all right. So the probability of, I'll say 6 dash. So the probability of not 6 is 5 on 6. And just so we are clear, the probability of rolling a 6 is 1 in 6. Now, if I add these two together, 5 on 6 plus 1 on 6, it gives me a whole. Okay, so what I could have done was 1 minus, but I'll show you in the next one. What if they just give you just the probabilities? This is a common type question. Find the probability of an event if it's complement. So the probability of the complement is 13 on 20. Now we know that the probability of my event in this case is going to be 1 minus the probability of its complement. Okay, and I'll keep it consistent and I'll use the dash, so I'll use the dash. Okay, so in other words here, I can write it as 1 minus 13 on 20, and that's just going to give me 7 on 20. So that could be the probability of my event. Okay, now I'm using this formula up here, 1 minus. Okay, now I wrote it the other way around as well. They are both acceptable. Okay. They both add up to give you 1, so you can kind of swap those around. Now, this is where you're probably most likely to see something like this. So what's the probability of tossing a coin 3 times and getting at least 1 tail? Now, what I could do here, and I'm going to do a real quick tree here. So if I'm tossing a coin 3 times, what that means is I have 3 events. And so if I draw a tree, what you can see here is which are the ones where I get at least 1 tail. That's at least 1 tail. All of these are at least 1 tail, except for this one. Okay, there's no tails there, but all the other options have at least 1 tail. Now, I hope what I'm going to do, I'm going to spend a little bit of time here to make sure that you guys are all clear with this. If I take this route, it means that I've got 3 heads. This route here means I get 2 heads and a tail. This route here means I get a head, a tail, and a head. Head, tail, tail. Whoops. Hopefully you're getting the idea here. Tail, head, head. Tail, head, tail. Tail, tail, head, and then triple tails. Okay, so all I've done here is I've just kind of followed the path. Tail, tail, tail. Tail, tail, head. Tail, head, tail. That's the idea. Now, what you can see here is at least 1 tail gives me all of these. Now, what I could do, I'm going to show you multiple ways. Probability of at least 1 tail, I could write as, I could have done this whole thing and could have been, what do you call it, is 1, 2, 3, 4, 5, 6, 7, because there's 7 favorable outcomes out of a total of 8. Okay, so I could have done that. The other way that I could have done is the probability of at least 1 tail. Let me do this. Equals to 1, take away the probability of, the opposite of at least 1 tail is the probability of all heads, or 3 heads. Okay, because if I don't get 3 heads, that means I get at least 1 tail. So can you see how these two are complementary events? That there and that there, those two are complementary. It's either one or the other. And what I'm saying here is I could have calculated it as 1 takeaway. The probability of getting 3 heads, we learned, was 1 out of 8. So if I calculate 1 take away 1 on 8, I'm also left with 7 on 8, which is the same thing. Now, what that could have been really nice for is I could have avoided drawing a whole tree. And it's just kind of gives you a quicker method when you use the word at least. Anyways, I hope the idea of complementary events makes sense. Good luck, all the best, and I'll catch you in the next one. Bye.